DOT SPPU. Sorry, the coordinator of the FDP as well. He's a chemical engineer and he worked with Matlab Industries in chemical division for 2 years post his BTech. After that, he did his PhD with great Professor B.D. Kulkarni from NCL Pune. Dr. Nandi is a recipient of very prestigious CSR fellowship for his doctoral research, and he has a total 19 years of experience in academia as well as research. His research work mainly, includes process system engineering, biofuels, and application of data-driven methodologies in chemical and allied fields. He is also associated with couple of chemical and biotech industries for process optimization strategies. Dr. Nandi has worked with MIT Pune for 12.5 years, and presently, like I said, he's at the Department of Technology as associate professor since last 6.5 years. He has published almost 22 articles in some topmost chemical engineering and related journals. He's also academic guide for some of the doctoral candidates. Some of the candidates have also awarded with this coveted Prime Minister Fellowship from DST SOP. He's also a reviewer of some of the journals from leading publishing houses like Elsewhere, Wiley, Taylor and Francis, etc. It is a pleasure to introduce Dr. Nandi to all of you, and I hope you will enjoy his talk on modeling for sustainable fuel. And I request all the participants, if you have any questions, to please post your questions in the chat box so we can take them one by one at the end of the session, or you can ask them at the end of the session as well. Okay, so again, welcome you all, and Nandi sir, over to you.
Thank you, sir. So such a nice introduction. Thank you. Really appreciate Mandar sir. And as Mandar sir said, those are fine, but definitely in order to make it more interactive, you are welcome to interrupt in between also. So in order to make it more interactive, because we understand it's post-lunch and heat is also increasing. So it will be better if we interact. Okay, so not an issue. We can interact also in between. So I'm perfectly okay with that. Hopefully my screen is visible, right?
Yes, sir. It is visual, sir.
Okay, good.
Yes, sir. Yes, sir.
So my content slide is visible, right?
Yes,
Yes,
sir.
sir.
Good. So now let me go. No, this is not in full screen mode. Okay, so let me do something. Okay. So I think now this will be visible. Okay. So, or better, I should go to PPT mode. That will be more better. Let me go to full screen PPT. That will be better. Is it full screen mode is visible?
Yes, sir. Yes, sir.
Good. So
Yes,
content is not needed. So we'll discuss couple of interesting things. So first and foremost, I should say that many of the time when we think about modeling, we think it's a very big issues, so much math, a lot of complex things. So I want to focus some aspects in which maybe some thorough understanding of the process can be unearthed if you analyze it. Instead of modeling, I should say analysis. That should be the right word. So to just keep the ball rolling, since morning we heard about biorefinery, and then Dr. Sharab Ahmed talked about the biochemistry and biotech aspects of how to develop engineered gene and all those, and always there is a mixture of products. A lot of different products are there. And we are gathered here for sustainability, and we understand that need and necessity of biofuel. And couple of very good questions asked in morning session. If it is important, then why it is not so much commercialized? So definitely there are few challenges. And in this talk, I want to highlight a couple of them as well. Definitely, we have to admit that it's still in a nascent stage. So majorly, we are getting fuel which has high heating value, and gradually we are trying to make some sort of substitution to petroleum-based fuel. And because petroleum-based fuel, all the engines, IC engines and all those are developed based on petroleum-based fuel. And so we try to mix to certain extent so that no modification of equipment is needed. We need to look after that. In Brazil, they use 100% biodiesel, but their engine modifications is also done. So that is the technology, both goes hand in hand. And as Dr. Shada also mentioned, that though we say we are technologically advanced, in many of the cases, first generation, again, for government of India is also giving subsidy, and subsidy to the molasses-based ethanol. So to be honest, on sustainability, still we are much backdated. We have to admit it, and that's why we are trying to use a minor modification of the equipment, and so that we can use it. But definitely, we have a great sense for the environment, so we want to reduce greenhouse gases, and we should try to develop some emission control norms. So that because day by day the emission norms are becoming stringent, so we should try to blend something so that we can able to meet up the norms. And that is the purpose of using and the focus on biodiesel and all those. So we know that generally vegetable oil, animal or waste can be esterified to produce biodiesel, and we get glycerin as byproduct. And generally methanol or some other thing is used, and those are getting recycled. So you can say this recycle itself is also a good thing, that you are recycling it. That itself is one of the important pillar of sustainability. So we are not throwing them out, we are reusing it. The catalyst as well as methanol, we are reusing it. Initially, the catalyst was homogeneous catalyst like KOH, NOH, but gradually we are moving towards solid catalyst so that we can use it. They may not give very good productivity, but the usage, it can be done again and again. So in a way, those are more sustainable. But we have to admit that sustainability comes with a whole lot of challenges. So one of the challenge, let me come to the next slide. So look at this slide. Is the blending of biodiesel slide is visible to all? Blending of biodiesel.
Yes,
Okay, good. So
Yes, sir.
Just we have to accept that diesel calorific value is much higher. Look at the diesel calorific value and look at the biodiesel calorific value. Diesel calorific value is 129,488 BTU per gallon, whereas for biodiesel it is much lower. So it is 119,500, 10% less. So the same thing, if you see again that the STM standard I have mentioned. So calorific value is less. As calorific value is less, so obviously you have to burn more biodiesel in order to get the same torque, same thrust. Again, another drawback is kinematic viscosity. The kinematic viscosity of diesel is in the range of 1.3 to 4.1, whereas it starts from biodiesel 4 to 6, and that is also based on STM specification. So that is the need of engine modification. Without engine modification, we cannot use complete biodiesel. So what we are trying to do is that some blending in which we can able to meet up the diesel specification. Specific gravity also, if you see 0.85, 0.88, you think small change, but it is not so small change. 0.85 and 0.88 is substantial amount of change. 0.3 divided by 0.8. So 0.03 divided by 0.8, so 5%. 5% density change is substantial. Now comes the major thing. Why biodiesel, the energy content is low? Now comes the chemistry. The carbon content of diesel is 87%. Hydrogen is more or less equivalent, 13% for the case of plain diesel, which is nothing but plain hydrocarbon. For biodiesel, it is 12. But carbon content, 87% is reduced to 77%, and oxygen is more, 11% oxygen. So I am not giving any final verdict here. We'll again come back how we can do better on it. But these are some challenges. So why there is a thrust, there is a need and necessity to work on biodiesel, but miles to go. Because these are the challenges, that one is viscosity, one is heating value, and heating value is because of that thing. We are suffering carbon, and not only we are suffering on carbon, but we are getting more and more oxygen, which itself has a pitting tendency. They may corrode your entire that engine environment. So these are real challenges. Apart from that, so if you go to sulfur, so we are happy. Sulfur content is काफी less. Boiling range, if you see, boiling range is also higher in the case of biodiesel. So that clearly indicates your ignition should produce more heat. The flash points are also higher. Cloud point is also, the cloud point of diesel is much lower. So as a result, you can keep it in fluid condition for a longer period. Whereas for the case of biodiesel, the core point and cloud point are much higher. So as a result, the range of operation is not, you can use biodiesel definitely in Sahara Desert and Africa, but you cannot use biodiesel maybe in Scandinavian countries until and unless you add core point depression and all those. So these are not, I should not say these are, better to say these are challenges instead disadvantages. So these are, and the basic purpose of developing this sustainability FDP is to come out with these points, the challenges and the questions unanswered. So we need to do something on that. If we can do it, nothing like it. So you can definitely add 4-point depressant, but unfortunately those are really highly flammable. So that may not be good for your engine. So those are questions unanswered. Now another data taken from the sources are provided below. So first I'm moving to right because it's colorful. So here I have taken from the source, that is Biodiesel Handling User Guide 5th edition from US Department of Energy 2016 edition. So you see that there are several types of esters are there. There are saturated ester, monounsaturated ester, polyunsaturated ester. We know all of this irrespective of our discipline, because we know now, because of heart ailment and all those, we know monounsaturated is better for as a cooking oil. So there's biodiesels are nothing but those are from all these triglycerides. So some of the triglycerides like canola, sunflower, all those, they have saturation content less. So in some of the cases, lateral oil show that as saturation content is less, they are giving very good biodiesel. But for something like palm, coconut, beef tallow, the saturation content is so high, and saturation content high is really that itself also asks for more chemistry and technological development in order to utilize it in proper fashion. Whereas olive, corn, sunflower, safflower, all those are giving good polyunsaturated and we can use it. But unfortunately, food for fuel or food for land for fuel or land for food. So as a result, most of the time canola, sunflower, olive, corn, soybean should not be used, and we should go for lard, beef tallow. But if you see lard, beef tallow, all those, their saturation limit is more. We need to do something on that. In left-hand side, I'm showing kinematic viscosity. So the bottom portion, so that 100% biodiesel, if you see, so 100% biodiesel, the initial kinematic viscosity is very high, and it is falling down sharply as temperature increases. Whereas for the diesel, good quality diesel, if you see their kinematic viscosity is in the range of 4 to 2. So kinematic viscosity of diesel, which is people are using, it is not changing too much. It is in the range of 2 to 4, reasonable enough. But look at biodiesel, it is moving to 14 or so. So that is the drawback, that is the challenge. The viscosity is so high. We know we have a couple of heat and power and mechanical faculty members associated with us. So it requires a holistic thinking. So can we do something on that so that we can, so if we work in the range of 60 to 70 degrees centigrade, the kinematic viscosity is coming down, no doubt of it. But problem is that you are storing at 20 to 30 degrees centigrade. So if you are storing at 20 to 30 degrees centigrade, at that temperature, the viscosity is so high. So the itself fluid flow is getting disturbed. You may say my engine is very high temperature. In that case, all path leads to Rome. Everything is fine. But you are storing it at reasonable temperature, maybe room temperature. At that temperature, the viscosity of, as you go towards pure diesel and more biodiesel, purer biodiesel and more diesel content, the kinematic viscosity is very, very high. And that's why I kept that right hand side, that the viscosity becomes high because of that chemistry aspect of it. So I'm just talking about some challenges. Now let us come to what, as an engineer or technologist, we have to give some solution. So we were working with something very small scale, lab scale work. And we thought of just to see that how we can able to predict the blendability of diesel with biodiesel. And case mixing rule is nothing but that the mixture blending is nothing but the proportion of component I multiplied by its density. So it's very simple, just a law of average. So I have two components. So component 1 mole fraction multiplied by its density plus component 2 mole fraction multiplied by its density. So that's nothing but case mixing rule. And based on that, we just thought of, if we take any property of a blended fuel, may it be kinematic viscosity, may it be pour point, may it be cloud point, may it be flash point, even may it be calorific value, that heating value. So let us try to predict using this simple mixing rule. So we know that it may not be correct, but let's give a chance. So that's why just we have taken that, what is the property of mixed blended fuel is nothing but the proportion of biodiesel you are taking in the mixture, and 1 minus x is the, because it is a binary mixture, so the how much component of petroleum based diesel, that's why PD is taken. So it's very simple unitary method. And with that we can able to predict. Please look at the data. So nothing to hide and everything is there. So experimentally we have checked, and our model can able to predict quite good accuracy for kinematic viscosity, even pour point. Okay. Now we are thinking, and that is the process. The modeling starts like this. So modeling is not a very complicated thing. It starts, why this simple thing, why it is valid. So we have done some literature search, and a seminal paper of Nature in 1949, when just India got its independence. During that paper, and that paper got more than 2,700 citations as of today. So they predicted that blendability of any mixture can be represented by a simple additional rule followed by some thermodynamic parameter. So in this, there is some term Gij. So where it is nothing but between the interaction between I and J component. In this case, we have considered two components. One is petroleum-based diesel, another is biodiesel. Definitely, we know that those are not only two components, but all the diesel components are nothing but more or less those are hydrocarbons. So we consider those hydrocarbons are one of the component. And the other one is that biodiesel. In biodiesel, it is nothing but fatty acid methyl ester. And we have checked meticulously. All of them has very low dipole moment, and we checked that their interactive parameter is not so much pronounced until and unless you are making very concentrated solution. So we have checked that in dilute solution that the interaction parameter is not that much prominent. And later stage, we have seen that you can definitely do much better option if you work on activity coefficient models and all those. I'm sure some of chemical engineers are with us. So actually, GIJ is nothing but the interactive parameter. So we have, let us consider A is nothing but petroleum-based diesel, that is nothing but hydrocarbons. Let us consider hydrocarbons and FEM. So hydrocarbon interaction, FEM interaction, hydrocarbon-FEM interaction. So as long as your FEM, that is biodiesel content is less, the interaction between hydrocarbon and FEM is almost of the identical nature. And you can cross-check it using by any activity coefficient model, maybe Van Laar or Margol's, or even higher any activity coefficient models. But that is valid only for dilute solutions. So up to certain dilution, it is valid. And exactly that thing is shown here. So if you see, now I'm showing that fraction of biodiesel. If you notice fraction of biodiesel, as long as those are less, the model can able to fit it well. But as your biodiesel content is keep on increasing, the deviation becomes more and more. The deviation from the ideality becomes more and more as the biodiesel content is keep on increasing for the case of density, for the case of viscosity also. So that clearly indicates that the interactive parameters, so the activity, because we know that for dilute solutions, we take activity coefficient is equals to 1, because those are in dilution, those are not so much pronounced. So we can take this model to the simple model as long as in dilute solution. But definitely as we go towards higher and higher end, we need to look after the interactive parameter. And in that case, we can use the dipole moment, interaction, and all those aspects. And we can able to predict exactly what is the viscosity and everything. Okay. So we were happy that anyway in India hardly more than 5% blending is done, so we can able to predict quite accurately. Then this is for our lab data, and then we thought about, so let's check it for some published data, and so look at this is also our lab data. So we have, these are not from lab data, these are also some published data. This is available in Industrial Engineering Chemistry Research, the detailed reference is there. So if you notice that density is also matched 0.88, 0.88, 0.85, 0.852, 0.864, 0.864, 0.870, 0.868. We have nothing to hide. So CTA number 50, it was predicted as 51, 54 is predicted as 55.8, 53 as 55.9. So, and even higher heating value. The heating value of the blended diesel are also able to predict in quite good accuracy. So we became fascinated and we searched for some more data. And people have used Minitab model, Joshi and Peg has used, and they developed some complex model. And with our simple model, if you notice, so the ash one is the Joshi Peg model. The blue one is experimentally obtained value, and our proposed model is shown by the orange color. So if you see, even our simple back of the envelope model can able to predict the trend quite well. It may not be look at this trend, that is giving some insight that I am talking about. So look at the trend. So when there is no biodiesel, our model is fitting well. Our model is fitting well, better than a Minitab model. Our model is faring better than Minitab model. The same thing for the case of cloud point, same for the pour point. However, our model is not fitting good when we have concentrated, when the concentration of biodiesel is higher. So again, pure biodiesel is nothing but that's only unique that you have only FEM-FEM interaction. But when you have biodiesel higher concentration, that time the interactive parameters need to be considered, and that clearly indicates that there is a chance of improvement. And that insight is obtained from that simple back of the envelope, simple additive model. Okay. So what to be done? So then we tried even for some, these data are taken from Sahu et al., who are from IIT Delhi. They have set up a pilot plant for biodiesel. In continuous mode, they were running it. And their paper is also published in the journal was Asia Pacific Journal of Chemical Engineering, 2011. So from that we took the data, and our model can able to predict for kinematic viscosity, and they have taken two types of oil, one for Karanja, another for Jatropha. And that was the work going on with IIT Delhi because that time they had a big funding from Indian Railways, because I feel some of you know, because right now Indian Railway is running the goods some of the goods train are run in blended biodiesel. And in 2009 to 2010, that Indian Railway has given a huge project to IIT Delhi to develop that scale-up studies in order to do the blendability aspect. And since 2015 or so, Indian Railways has blended biodiesel, but they have not blended it for regular passenger car because that requires speed. But all those goods van, they run at lower speed. So they are still running couple of their this slow-moving goods vehicle on these blended biodiesel. So these data were developed during that phase. So the result was published in Asia Pacific Journal of Chemical Engineering, and we took that data. And even for both Karanja and Jatropha, because that time Jatropha, that plantation was there in the barren land of Indian Railway. And Indian Rail thought of that from Jatropha, they will extract Jatropha oil, and from that they will do diesel and they will utilize it. Though that particular thing is not materialized, but still they are procuring some of the biodiesel and getting it mixed and running the goods vehicle. And that's why they focused on Karanja and Jatropha. And so those data we can able to, the trend is picked up, but definitely if you see, the variations are more in the mid-range. In the mid-range means when you are increasing the concentration of biodiesel more and more. So that I'm not giving any final word, but that clearly indicates we need to focus our attention more on interactive parameter. If we can develop some good model, definitely it will be beneficial and useful. Okay. So now I should mention that this model is very simple and nothing but additive model. Now the additiveness is, if you see in the mid-range, if you see here also, so here it is matching, here it is matching, somewhere in between it is not matching. So that clearly indicates the linear fit is not there everywhere. So that clearly indicates there is a scope of non-linearity. And that non-linearity is there everywhere. So here I have started my discussion with simple blending. So that is only, you have the finished product, you are just doing the blending. So we have started on the surface. So just even in the blending also, you start from back of the envelope simple model, and that also indicates that for higher blending, you need to think more. And that is the need and necessity of model. Now, this is not from our paper, but we have also done some work, and this is from some published paper. So the molar ratio and catalyst concentration. So ethyl ester or methyl ester, whatever you are taking. So that is your target. So you want that to be as high as possible. Definitely catalyst concentration is one of the key variable. Molar ratio of, that is oil to ethanol ratio, is important. Time of esterification is important. There are so many factors. So let me come to next. So even temperature is an important parameter. Catalyst concentration. So what I want to highlight is that there are various parameters. So let us consider there are 4 parameters. One is that your temperature. Second is that molar ratio. Third is that catalyst concentration, and also time of the reaction. But unfortunately, many of the time what we do, we just keep, that's why I have just plotted one above another. So look at these. So if we see time, so initially we see that initially the conversion is low, and we see that a conversion is becoming very good at 100 to 120 minutes. So almost like 2 hours, the conversion is good. And we think that, okay, this is still non-linear, but here we are getting non-linearity only in just as a line, a non-linear line. But in real life situation, it is not a line. Just try to understand, it's a curve. So here the y, that output is nothing but your desired conversion. But input, you have only one single input. That's why you are getting it a curve, just a curve, non-linear curve. But that becomes a surface, that becomes a curved surface if you take 2 together. And my point of discussion here is just try to understand. So we are familiarized ourselves with Euclidean geometry. In Euclidean geometry, we cannot perceive more than 3-dimensional aspect. So out of 3-dimensional aspect, 1 dimension is already taken by the conversion, that is methyl or ethyl ester output. So maximum you can plot 2. Either you can plot catalyst concentration, molar ratio, or you can put molar ratio, time of reaction, or you can put temperature, molar ratio, temperature, catalyst concentration. So some combination of these. But try to understand that thing, the pattern is changing entirely different way. Entirely different way. So none of these are matching. So in some of the cases, it's like Aladdin ka, that flying carpet. Sometimes it is something like Matlab, earlier Jamana pe Matlab ka jo signal. And sometimes it is just like a flying chadar, something like this. So in various dimensions, they are, and please try to understand, but still they are not giving the complete picture. As I am telling, this is not giving complete picture. This is telling it's non-linear, good. But this is not the actual non-linearity. Here, if you see, you are thinking it is coming down and moving up, but it is coming down in one space. Not everywhere it is coming down. In some of the spaces, it is moving up slowly and steadily. In some of the places, it is coming down and moving up. So enter that gamut, we cannot able to express. So here I am showing that it is 2D, you are moving to 1D. And actually it is not 2D, it is multidimensional. And with Euclidean geometry, what we perceive, by that we cannot see it. And actually to understand the process, you have to go to much higher domain, and you have to use support vector regression or some other tool, or you have to reduce the variable by principal component analysis and all those. I'm not going to any depth of those, but I am telling the need and necessity of those advanced modeling in order to understand and comprehend the process better. Please try to understand, though this is not the right dynamics, even this is also not right dynamics. This is better than 2D, but still it is giving only just some perspective, not the complete perspective. And that needs, so we should take that in much higher dimension. And in very simple term, what support vector is doing, support vector is taking, there is no limitation on the dimension. So they are trying to take it in much higher dimension. Just think of that thing. So you have crumbled any paper. If you have crumbled any paper, that becomes just like a very bad shape. But if you take it open, then you can able to visualize. So almost everywhere you can do this experiment. So you crumble any paper, and if you open up, you will notice that everywhere the point of crumbling are nothing but a straight line. those are nothing but a straight line. So exactly that support vector regression is based on that concept. So if you can take if you can blow up any and every process to much higher dimension, so they can be separated by linearity. And in that higher dimension, you can take linear transformation. But to what should be the ideal dimension? That is a big question. That is a big question. Okay, so now let us come back to another very handy tool. So now we are familiarized ourselves with Matlab, and so many things pirated or licensed copy are available with most of us. And even Matlab is good that for 30 days trial they give free, and even you can renew it for at least 1 or 2 more times. So it becomes really handy. And in Matlab we have a neural network toolbox which is inbuilt. So as I have considered, in this case, I have considered only 4 parameters. So the parameters can be even more. So I have considered only 4 parameters: molar ratio, catalyst concentration, temperature, time of reaction. Sorry, there is a mistake, temperature. I forgot to mention E. So my sincere apology for that. So I have considered, because those even the study we have done, as well as a whole lot of study published, they have observed that molar ratio of the oil to methanol or ethanol, that ratio is important, catalyst concentration is important, temperature is important, and time of reaction are important. And these clearly indicates those are connected non-linearly. So we are trying to push it to neural network, and it's nothing but a black box. So once upon a time we were coding it neural network, and I have coded it in Fortran for my PhD from National Chemical Laboratory. And the ethics is that I do not have that copy, because that was a property of National Chemical Laboratory, and I have to write it in the agreement that I will not take that, and even I will not work on neural network for next 5 years or so. And that property is NCL property, and with that we have also NCL has done a couple of I should say project as well as consultancy. And one of the Reliance soft sensor were developed on that neural network architecture. And definitely because NCL has funded me my PhD, so obviously it should be the property of NCL. But later, when I have observed that I need not, because I have coded it, if I do it from scratch, again, almost the similar thing I will do. Again, there will be conflict of interest. So that's why for 5 years I have not done anything, and slowly I have observed that neural network is freely available in Matlab, and I started working on it. So, and it's there are a whole lot of advanced features available, so anyone can utilize those. So you can connect the dots, the inputs with the outputs. But what is the fuzzy is the input and output are connected through something called hidden node, hidden layer. So how many hidden nodes? There's no specific guidance. And even nowadays, people are talking about pruning of network. Pruning means, in this I have shown each and every all connections are active, but there is something called pruning. So sometimes this connection is on, sometimes this connection is off, and and that actually helped to develop that recurrent neural network, and that has its own advantages. So anyway, without going to that detail, so what my purpose is to make you aware that the nonlinearity can be captured by neural network, because all these inputs can be transformed nonlinearly using logistic sigmoid or tan hyperbolic function, and you can able to predict the output. But the problem is that what is the obvious connectivity, and all these are connected using something called weight. And development of neural network is like we do exercise to build our muscle. We do read and discuss in order to build our mental intellect. So exactly like this. So in neural network, you are feeding data, and based on that data, it is getting nourished, and all the weights are getting updated. And finally, you are getting optimal set of weights, so that given any set of input, you can able to predict the output in very nice manner. And exactly why it is called neural network? It is called neural network because it is using our own neural connections. So we are fed with some ideas, some concepts, and that ideas and that concepts, we can utilize it for something else. And exactly that is the purpose of this sustainability workshop. We'll try to make you some of the fields which are niche and which are needed to you. And subsequently, we need to think, rethink, learn, unlearn, relearn to develop that connectivity among ourselves so that we can really take up some really challenging aspects in years to come and also what we are handling now. One of the interesting thing I'll talk about a bit later. So development of neural network is nothing but to figure out the weight, that connectivity, which so the weights are so standardized that given any set of input, you can able to predict output. That's good. So we are happy that we can able to predict ये अच्छा. So इसका कितना amount of glycerol बनेगा, कितना amount of ethyl ester बनेगा, or methyl ester, whatever, we can able to predict. Now we become greedy. So it's like that Adam and Eve. So we ate the apple. We ate the apple. So now we are telling that, okay, we can able to predict what will be this. Now we are logical. So if we know this, so now I become greedy. I am thinking. So can I say what is the molar ratio? What is the catalyst concentration? What is the temperature? For how much time I should do the reaction so that I get 97% ester with 54% glycerol? Can I figure out that thing? Yes, that is possible. And that is nothing but inversion of model. And optimization is nothing but that same thing. What is optimization? In optimization, you are trying to get maximum value of the output achievable. And what is the input in which we can get the maximum output? So that neural network based model can be invertible so that we can able to figure out what are the set of input by which we can able to get the desired output. It may so happen we are expecting too much. We are expecting 99% ester. We are getting some molar ratio 20.4, maybe catalyst concentration 11.5. That may not be feasible. So finally, at the end of the day, this is nothing but doing data manipulation. Now, that is the need and necessity of amalgamation of various branches. So as a data handling tool, it will give some result. But as a person, we need to understand whether that is logical. It is telling the temperature should be 110 degrees centigrade. But we know that for ethanol, maximum 87 degree. For methanol, maximum 65 degrees centigrade is the maximum we can take it. We cannot go beyond that. So that clearly indicates what is possible, what is not, what is feasible, what is not. So only modeling does not mean anything. So we have to develop some feeling and necessity of the modeling, definitely keeping an complete confidence on our understanding of the phenomena and process. And so if this particular idea is also translated, I think that is good enough. And I should say neural network is not only model, even you can go for other type of nonlinear, simple nonlinear regression, which can be done in Excel also. So I have given that example also, not for this context, some other concept. So any query so far? Any query? So better to be a bit interactive. So anyone, any query? Or it becomes too much boring?
So which instrument you are using to measure the viscosity? Redwood viscometer as we have in our instrumentation lab, or any other specific sophisticated instrument is
Redwood
utilized?
viscometer can be used, but better to use cup and cone viscometer, like we have used Brookfield viscometer. Okay, we have used Brookfield viscometer because the A is much better. Accuracy is much better. But
Okay. How
redwood is also.
refractometer can be utilized, sir, for the biodiesel purpose?
Can you repeat?
Sir, can we use refractometer for any kind of specific studies relevant to the biodiesels for student projects?
Definitely you can use, but I'm not very sure, because refractometer is the thing that I'm not, because you have to infer. Okay, so by refractometer, what will you measure? So if you
Refractive index changes
refractive
only, sir.
index, right? So refractive index is not that way, because what is refractive index? So how much denser it is, basically. Okay.
Yes,
So
sir.
basically, refractive index is telling some extent density. Definitely, it is related to viscosity, but
Because
not
viscosity is relevant to the density, and I think that whether a small project can be given to our UG students, undergraduate students only.
I understand. I really appreciate your out of the box thinking, but just try to understand that refractive index itself is a very require more sophistication skill to just adjust refractometer and get the exact reading. Am I correct?
Yes, sir. I have we have an instrument. That's why
You
our
have
facilities
instrument.
are there with us.
Definitely, that academic project can be done. Academic
Yes,
project
sir.
can be done, but for practical purposes, it is not so much appealing to me.
Yes, sir.
Is simply because that
I agree.
refractometer itself is so much where time is needed, and finally you will be inferring with density. Density you can simply measure even by simple that
RD bottle.
hydrometer or density bottle.
Yes, sir.
Okay,
But
so
just to make our students, sophisticated instrumental handling, which is very simple to use, and learn about the methodologies only.
true. So definitely refractometer can be used, but it can be used. Try to figure out. So nothing is yes. So try to figure out how the diffractive index can help you to. Can you correlate something with a flash point? Okay, because
Okay.
flash point is another important parameter, and that depends on that molecular interaction. So just I'm telling vaguely from my chemistry perspective. So
Thank
if
you.
the flash point may be inferred, and again that is nothing but a soft sensor. So measuring the refractive index, can you predict flash point? Because flash point actual measurement itself is tricky, and many of the time comes with plus minus 5+ % error. Okay, so even
That's a great
flashpoint and something like this, that will be really a good point.
Okay, sir. Thank you.
Okay. So anything further? Okay, I lost here, so let me go to my presentation again. Is it visible?
Yes, sir.
Okay. So now we talked about the modeling part. So neural network is nothing but only one such model. So I am trying to make it general. The need and necessity of model is to unearth the process. Many of the time we think experimentalists are definitely experimentation is needed, because I have made a cake. So I need to test it. Until and unless I test, how I can say it is good or bad. So experiments are needed, but definitely models help to unearth it in better fashion. And modeling is helping you to look for those points. So exactly that I was talking about. So in last slide I was talking about, so your target is higher and higher ethyl ester. So you can design your experimentation in such a range so that you will get higher and higher ethyl ester. So that design of experiment can be done by modeling. So that is design of experiments. And it will reduce the load of randomized experiment. Generally we do just different sets, different combinations we keep on doing. And it is two sides of the same coin. So experiments are needed, but definitely modeling also unearths some of the hidden facts. And the most important striking thing is that it can able to predict performance of unseen condition. Just try to understand this scenario. Let us consider, here is a point. Okay, so if people are on this, so they are thinking, okay, so yeah, it will come down and again move up. But if you look at this, it sharply fall down and sharply tuned up. Or maybe if you think this particular, so in this case there is no such depth, so it is just a small kink and it moves up. But in this case there is a deep down. So all these things, until and unless you develop some sort of we cannot able to do experiments for each and every conditions. We cannot able to do experiments for each and every conditions. But modeling in a way can able to provide some understanding of which are the zones. So definitely some experimentalists will try to prefer this zone, because in this zone the operability is much better. Then though it may so happen this particular is much higher peak, but this peak that operability domain is very less. With small fluctuation, it may drop down to very low biodiesel ester. So then people will prefer to work with a molar ratio of 10 to 12 rather than molar ratio of 2. In molar ratio of 2, it may give good, but even a small fluctuation can lead you very deep down. And experimentally, how many experiments you do, it's almost impossible to get that entire scenario. And point again, I'm telling again, it is not the complete picture. Again, it is only 3D representation of actually 5-dimensional space. Why 5-dimensional space? Because all these 4 are input, and presently I'm talking about ethyl ester. So all those 5 dimension, how it is behaving, nobody knows. Nobody knows. So that is the need and necessity of modeling, to unearth more and more understanding to predict unseen condition. And as I talked about, that we can do trial and error, that guess what is good, what is bad. So we want 90% conversion. So what are the good conditions? We can, by trial and error, we can hit or we can miss. So that is one sort of thing. And then we can do the inverse of modeling to get the best target. And that is nothing but structured mode of optimization. Now, in this particular slide, I want to show 2 important things. So I have defined 2 objectives. One objective is I want to maximize my fatty acid methyl ester or ethyl ester, and I want to maximize my glycerol, because these are my finished product which are sellable. So I want all to be either I want a very high conversion to glycerol. So look at this particular point. So this is leading to very high glycerol, but this has very high glycerol, but at low conversion of biodiesel. This one is leading to very high amount of biodiesel, but at low conversion of glycerol. So I want a Pareto front which is telling that, so there might be a mixture of them in which both I have, so this is a point why it is called Pareto. Pareto means non-dominated. So I cannot say this is a better point. Why I cannot say it is a better point? Please try to understand. Because in this point, I am getting glycerol. I am getting glycerol maybe 80%, but I am getting glycerol 90%. So I cannot say this is a better point. In this case, I am getting I can say this is a better point in other way. I can say it is a better point because here I was getting biodiesel only 20%, but I am getting biodiesel 40%. So that's why these are called non-dominated. Why those are called non-dominated? Because you cannot improve biodiesel yield without compromising on glycerol. In the same case, you cannot improve your glycerol yield without compromising the biodiesel. So looking at this, we cannot say which is good, which is bad, but that good optimization techniques like genetic algorithm and all those, they can able to figure out all the operating conditions by which you can able to get a mixture of all of them. And then with proper analysis, you decide, maybe this is a good point, or maybe glycerol का उतना market नहीं है. I want more and more biodiesel, so I will operate on this. Maybe sometimes down the line, glycerol market will boom. So then I will move towards this region. So that flexibility will be provided, and that is given only by thorough understanding of the process, in terms of modeling and optimization. So here I have defined my objective as the maximum quantity of biodiesel and maximum quantity of glycerol. I can think reverse way. I can think my objective is to minimize time. My objective is to minimize cost. So my objective is not to maximize. Now my objective is to minimize. I want the product at minimum time, at minimum cost. Now in both the cases, the ideal scenario is that 0 time, 0 cost, that will be the best thing, but that is a utopian, may not be possible. So I will try to take all the initial conditions trying towards this end so that I can get all my product at minimum, as minimum time as possible with minimum cost. Okay, so our process understanding will definitely help us to define the process and its objective. And neural network or genetic algorithm, those are nothing but like arsenal. And good that in Matlab, both of them are available. So only thing we need to stick to our discipline and try to utilize it as a tool, but judiciously and thoughtfully. So that's why I've given these two cases. It's not that every time we go for maximization. For what purpose we are going maximization? For what purpose I'm going minimization? We can do mix and match. I want at minimum time, maximum fame. So in one, I should go minimum, another maximum. So that type of different combinations we can formulate. Now coming to another important, very recent paper. So I'm sure there are many heat and power and mechanical faculty members and research scholars with us. Now, biodiesel is produced, and so there are different types of biodiesel. B0 is without biodiesel, so that is pure diesel, and B20 is 20% blending, B40 40% blending, 60%, 80%, and that orange is 100% blending. So the first graph is telling speed and torque. So as expected, diesel has a higher torque, and already we have said why, because the calorific value is higher. So all the time, diesel has a much higher torque for any speed, and that can never be met by biodiesel. And pure biodiesel is the very last one, obviously, because but a blended thing also, it drops, it falls. Now comes to that brake specific fuel consumption. Now look at this. So if you want to get this RPM speed, so you have to burn some amount of fuel. If you use diesel, so please look at, you can use diesel much less kg per hour. You use much less kg per hour, whereas for biodiesel you have to provide more. Why you have to provide more? You have to provide more simply because your energy content is less. But this also indicates another very important thing. Look at here. At 1000 RPM, your biodiesel is very bad compared to diesel. But at higher RPM, as you increase the RPM, maybe in 1900 and so that time, that indicates even biodiesel is doing a good job. Definitely it is inferior than diesel, and that also indicates, so here though it is shown that only biodiesel is inferior, it will be inferior, but definitely if we are using biodiesel, we should try to operate in that range. That's why we cannot use biodiesel for our passenger vehicle. We are using biodiesel for that slow moving vehicle, something like that. Okay, so we have to think about kahan kya use kar sakte hain. Now come to this thing. So brake thermal efficiency. So if you see, brake thermal efficiency of diesel is definitely high, and even for 20%, even it is better. And biodiesel is the really bad thing. So that clearly indicates 20% blending is good. So brake thermal efficiency is better. Now look at carbon monoxide emissions. For diesel, carbon monoxide emission is higher. As you keep on increasing load, more and more emission is there. But that is the goodness of biodiesel. So even if you increase load from 20 kg to 1000 kg, sorry, 20 kg to 100 kg, these are the fine thing. So from 20 kg to 100 kg, if I improve, so see the carbon monoxide emissions is increasing from 300 to 400, more than 400, 420 ppm for the pure diesel. Whereas for the blended, it is remaining almost same. 20% blended, it is remaining almost same. Even for pure biodiesel, it is remaining almost same. So this gives us some clue, some idea. We cannot use biodiesel everywhere, but where to use, how to use, which range to be used. And that's why that a combination approach, a synergistic approach of a heat and power person mechanical with biotech will produce the thing in best possible manner with understanding of maybe maths or chemical engineering background, and finally we'll do the actual experimentation with the type of engine available with mechanical. Now, this particular paper, I am fascinated. They have given so much data just to think about and ponder. So we talk about that, okay, we are good, that biodiesel is, we are happy. Biodiesel is reducing the carbon monoxide content, so we are happy. So biodiesel is very good, very good. Wait, look at here, hydrocarbon emission. Look at here, hydrocarbon emission becomes so high as you increase biodiesel. Hydrocarbon emission is becoming higher and higher. And for the case of diesel, it is remaining almost the same. Why is it so? Because as you keep on increasing more and more biodiesel, the cold start condition, because of density, viscosity, and all those, so it is not getting well mixed, and always there will be unburnt hydrocarbon. You will burn. You need to burn more. As you need to burn more, there will be sufficient amount of unburnt hydrocarbon which will come out. Definitely, you are improving in carbon monoxide, but at the same time, you are getting hydrocarbon, unburnt hydrocarbon. And it is simply because of that viscosity aspect. And again, that G aspects, that it is not well blended. So as a result, you are, in order to get that torque and thrust, you have to have sufficient diesel as you are mixing. So look at this. So in 20% blending, it is almost remaining constant. 20% is not an issue. But as you increase the blendability to 40 and those, it increases. It moves to 80, it increases. You go to 100%, it increases enormously. And for NOx also, in the case of NOx, because biodiesel itself is cooling down the environment. So as it is cooling down, so the NOx content is getting reduced. Everywhere NOx content is getting reduced. So some good, some bad. So genetic algorithm or any other type of optimization you can able to use. So just to figure out what type of operating condition you can utilize. I'm just skipping these two. So, and here I am just have drawn the overall approach that you develop. You get the data from experiment, you develop neural network or any type of model, and then use simulated annealing or genetic algorithm, anything type of here I have talked about genetic algorithm. That's why here I've talked about another good thing, simulated annealing, some optimization. And finally, that is very important. You get optimum desirability. What is your target? Definitely cost should be minimum. Specific fuel consumption, that should not consume huge fuel, because all the tanks are designed, maybe my four-wheeler has a tank capacity of 30 liter, and that is designed for diesel. But if I am using biodiesel and it requires, instead of 35 liter, it requires 45 liter, I cannot increase my tank. So that means I need to refuel it again and again. So that is a challenge. So the fuel consumption, that itself is a big thing. And definitely brake thermal efficiency, brake power, torque, all those are needed. So this is again from that particular paper. So just ponder for 2 minutes and see.
Sir, you are not audible.
Sir, you are muted. Please unmute yourself.
So far, I was not audible. Okay?
Yes, sir,
Yes,
for
sir.
last 2 minutes.
Yeah, last
Right now
one
you are
minute, sir,
audible.
you were not audible.
Are Babs. Okay, so quick. Now, am I audible? You should.
Yes, sir. Yeah. The
Right now you are
presentation you
audible.
need to share it again.
Okay. So really, my sincere apology for that. So is my screen visible?
No,
Not yet.
no. Right now it is not visible.
Some problem somewhere. I mean, it was visible, right?
Yeah, the screen was visible, but you were, I think, got muted. Yes, now it is visible.
No, it is visible.
Okay. So am I audible now?
Yes, you
Yes,
are
sir.
right now. You are audible, and your PPT is also visual.
Okay. So a quick recap. So what I have said that for modeling, so that can lead to your optimization, and by optimization you can able to get in which range of speed. So none of these slides were audible, right?
Sir, you went to the table and then it got muted, I think.
Okay.
So this
Good.
was, so we heard everything related to this, and then
Good.
afterwards,
Good.
I think, yeah,
Fine.
this
Fine.
one, I think this slide came up and then I think you went.
Okay. Good. Good. Good.
Yeah.
So this particular paper, they have claimed that they can do blending of almost 80 to 90% of blending, and they can able to achieve 1800 RPM is the ideal one. They can able to achieve close to 1800 or so RPM with a good torque of 60 and above, and brake power also almost 12 or so, and brake thermal efficiency of 0.4, and look at BSFC, that is the amount of fuel you require per kilowatt hour. So the amount of energy you for that kilowatt hour of energy, how much amount of fuel to be burnt, and they claim that only 0.22 to 0.23 amount, so it is almost comparable with that of diesel. That is comparable with that of diesel. With diesel it was almost like 0.21, and with even 80% of blending, they can able to utilize only 0.22 kg per kilowatt hour energy generation, and able to maintain almost 1800 RPM speed with 65 torque, and the cost is decent, and that's why they have defined some overall objective function desirability is 0.93. And there is a long table. As you go down, the desirability is getting reduced. The desirability is going reduced simply because the cost is increasing, or your BFSC is getting increased. BSFC is getting increased. That means you have to provide more and more amount of oil in order to get desired amount of energy. So a good combination they have done, and they have developed a neural network based model. Subsequently, they have optimized it, I think, using simulated annealing, and they come out with this type of thing. So forget about neural network or genetic algorithm or simulated annealing. So if you have some data, so you can utilize those data to unearth, because there is something in between lines. So these are not their experimental data. They have some experimental data initially, and from that they have analyzed. These are their experimental data. With this data, they have analyzed, they have developed some neural network model, and then they try to figure out which is the optimal condition, and this is the output of that. This is the output. So, and that is very much needed. Many of the time we do experiments only on couple of points, and there is a whole lot of amount of knowledge which can be extracted, which is there in between. and this can definitely help you to figure it out. And as I have said so much on neural network, so just maybe 5-10 minutes I'll talk on this. This is again simple. We were working with some biomethane potential, because today also for biorefinery, as well as Shadab sir talked about that biomaterial, we need to check that biomethane yield. So we become curious that because all these lignocellulosic material, they contain majorly lignin, cellulose, and all those. And we can quantify how much lignin, how much cellulose, all those are there. From that, can we quantify how much amount of methane we can able to extract? And we have done some simple, and all these are not neural network based model. These are simple, non-linear, multilinear, non-linear simple model which are developed in Excel. So initially we targeted linear model. So we targeted with cellulose, lignin, and hemicellulose. Can we figure out biomethane potential, BMP? So we cannot figure out any linear model. That clearly indicates that all are not moving in the same way. And obviously lignin is a tough nut. Then we have come out with, I should not say any of these model is very good, but nonetheless, we have figured out 3 good models. So these are again empirical model. We collected data from almost various types of crops waste, various types of grass from India as well as abroad. So almost 50 research paper we have compiled, almost total 700 plus data points we have. Napier grass, our bamboo, even this bagasse, whole lot of material. And this is not for a particular region. This is from India as well as abroad. And we come out with these 3 types of models. A quick point, please don't be under impression that this is a linear model. No, this is not linear. So everywhere there are log. So the third model, though, seems to be a linear, but there is a log lignin, log cellulose. And in left-hand side is also that log biomethane potential. So we can, presently we are confident that no linear model can able to fit it. But definitely cellulose, lignin, and hemicellulose content can able to give some sort of idea how much amount of lignin, sorry, how much amount of methane can be extracted out of it. And these are experimental data and these are predicted. And the model is developed subsequently. These are for unseen data. So we have developed model based on 700 some few data, and then we some 52 new data we targeted, and we observed that though it is not very accurate, but the trend is picked up and it can able to give some reasonable understanding. Kitna amount, and look at the range. The range is from 100 normal liter per kg volatile solid to it is almost 500 to 600. It's quite a long range, and it can able to predict with reasonable accuracy. Then again, the same thing, we became greedy. But then we thought of, so why to think about only cellulose, lignin, and even we have observed that hemicellulose is not captured at all. So we are trying to include hemicellulose because that is also a substantial part of it. Then some idea came out, and this is that thing. So we, the biogas yield we predicted, and ADL is nothing but cellulose. So ADL is lignin. ADL stands for lignin here. CL stands for cellulose, and HC stands for hemicellulose. So we targeted this type of model, and if you notice that model 1, that simple model is not good. So simple model, that simple combination is not good. Then we targeted some other combinations. And in those other combinations, gradually we have observed, apart from cellulose, hemicellulose, and lignin, we need to consider the free protein. We need to consider the amount of lipid all those things, the amount of lipid, the amount of fat, the amount of protein, and that gives even better prediction. So gradually we started with the linear, which is not so good model. Here I have not shown all the model. When we move to second model, look at the change. From first model, here all the coefficients are 1, that is, those are linear. So that clearly indicates linear is not a good fit. So R square was 0.45. But as and when we have integrated the, we have taken the power, and it becomes better, 0.45 to 0.67. So almost 50% betterment is pronounced. Those which were so poor has becoming much better. So that clearly indicates the need and necessity of non-linearity. And that's why I say non-linearity is in biotech industries, non-linearity is a rule. So many of the time we are familiar with linearity. Linear algebra is well developed, not non-linear algebra. We can do piecewise linear, but we have to move out of our comfort zone to venture into non-linearity. And similarly, if you see fourth model, though I've in this case, so again we have used that lignin, cellulose, hemicellulose, and we have included the protein, fat, and lipid. And in that also it can able to, so instead of simple these three things, if we add the protein, fat, and lignin, it can able to predict better manner. Okay. And the best model obtained when we are considering each of them and with reasonable non-linear coefficients. So this thing can be done even in simple Excel. So it's not that each and every time you should go back to neural network. Definitely. So that's why my point is that initially we started with simple, just back of the envelope additional model. Then talked about something on neural network because more complexities require more model. And even for biomethane potential, because never you will get a proper composition. Why I have not used neural network is simply because it's always in a mixed mode. So we know that the composition of what we are getting, that will always be with some sort of error. Okay. So if we know that error is there, so why to use so precise? Hammer is good enough. So hammer is a very crude, and so this type of simple Excel-based nonlinear model is a very crude model. But that is okay because I know that these compositions are not so accurate. So even if I use neural network model, so the performance may not be correct because I know that my accuracy is on the data itself. So that is another thing. So not that there are several whole lot of models. So which model to be used when and for what purpose? Okay, that need to be thought of. And now I'm coming to almost end of my presentation. So I'll not talk more on this. So this is again one of MTech work done by one of my student, Shweta. So she developed, so we started with simple from chemistry. So just to figure out that process calculation, so what are the composition, and so it is nothing but we have targeted municipal solid waste. So we visited couple of initially that Mahanagarpalika of Pune, and subsequently a couple of dumping station of Mahanagarpalika. We collected the material, we have analyzed it, and with that analysis we have figured out what is the concentration of carbon, hydrogen, oxygen, and there is always moisture because those are moist. So what are the components they will produce? They will produce amount of char, they will produce carbon dioxide, carbon monoxide, methane, hydrogen, moisture, as well as some sort of acetylene. And subsequently we developed some kinetic model based on some available data. And this is the ultimate analysis of the waste, of the almost 12 different waste from various regions of Pune we have collected, and this is we have reported that carbon content is almost 30%, hydrogen 3.4%, nitrogen 1.4%, oxygen in the range of 35 to 37, and some amount of ash. And we obtained some equations, and subsequently those are modeled using Matlab. And all these are nothing but coupled differential equations. Those were solved in Matlab environment. And unfortunately, we could not though initially Mahanagar Palika was very keen with the data, and they said that they will allow us to do some prototype, and even we were connected with some thing, but later it could not materialize. But we are confident about the model, the amount of time invested, starting from basic chemistry to development of the entire mass balance, energy balance, and every equations. And then we used our model to predict the performance of some published data, and it matched well. It matched quite well. So some already published data, we matched it, though unfortunately we could not do it. And but at the same time, one good point is that Serbia, there's a municipal corporation from Serbia. They are interested on this, and they asked me for the model, and I have shared it, because in India I could not see anything. And even Serbia, one of the municipality, they are using that model. They have definitely tuned it based on their climatic condition, and they said that they could able to revamp their gasifier based on our model. So that's only the good thing about this model. Apart from this particular paper we published in Energy Procedure, as of today, it has received more than 35 or 40 citations. And we have already, we have also done some sort of experimental data validation with our model, and which also gives reasonable good accuracy. But unfortunately, with in India, we approached a couple of municipal corporations, but in India, it's a really difficult thing, and it was done long back, almost 5-6 years back, and then COVID and all those. And but I am happy that Serbia has utilized and they have retuned their gasifier with help of some understanding, because their moisture content is different, their ash content is different. So with some discussion, they have changed it, and some model fitting were done, and subsequently they are using it. So that is the only good feeling on me about this. Now, why I am categorically included it? Because of this thing. Now we are masked. We need to be masked for. We are masked for last 2 years, and we do not know how long it will be. And at least coming 2 months, so definitely we should be masked, because Omicron and all those. So just in this, I am trying to talk about two economy. One is that linear economy, another is circular economy. So let us consider the case of mask. So now people are telling that don't go for cloth mask, you have to wear at least surgical mask. So for surgical mask, definitely we are taking it from plastic, making it, distributing it, using it, and disposing it. So kachra wali wo leke jate hai and is going to get dumped. So exactly we are working in this field for last 2 years with the simple N95 or whatever that surgical mask. But those are nothing but polymer. So that is actually causing more harm to our Mother Earth. Forget about the germs and all those. For the time being, let us consider those are also will not be there. But finally, they will really cause a much bigger harm in years to come. So can we devise something that in gasifier you can use anything and everything to make it gasify? Only this mask may not be, but can we take something, some biomass along with that, cut it in small pieces and do it? Can we gasify it and at least get some sort of, so finally what we are getting nothing but hydrogen, carbon monoxide as major gases. So at least we can utilize it. So definitely that will not give you a direct mask, but it will give us some sort of fuel, which we can utilize it And that is the one and important point of that circular economy or recyclability or sustainability. So now just I'm thinking, so if just I added this since morning I was talking, then I thought of that this is the real sustainable thing. Can we use something with our mask? So instead of just disposing of. So, and please try to understand, I know that we tried to initially, even municipal commissioner was very much interested initially, but when the data and all those are coming, gradually they become more and more different phase, I should say. But as a technologist, we should try to pursue, and that is not, as somebody said, that we have inherited not from our ancestor, but we have taken from our future generation. So in order to make future generation, because please try to understand those things, in years to come, nobody knows what it will do, that water clogging, that even those will really cause a huge pollution. So water flowing and everything will be really very bad. So just a thought. So I'm not giving any final thinking on that. So can we do something? So just open to you. Now, this is the last portion of my slide, and this is that from a particular paper. This is not my thinking. So even if you take out biodiesel, still it remains lignocellulosic biomass or a whole lot of other things. You can able to structure them in such a manner, or you can upgrade it to produce more and more fuel-like product. Okay. And in that case, quantitative structure property relationship or some molecular descriptor, all those things can be utilized. So I'm not going to depth because basically the loose thing I'm talking about. So whatever, so maybe you have extracted the oil, but chilka jo pada hai. So those are nothing but biomass. You can quantify them and try to valorify it to some fuel like. And in order to do that, what are there? So quantitative structure property relationship is nothing but you can able to predict what are there, from that what you can do it. And once you are doing it with chemical engineering and reaction engineering and catalytic aspects, you can able to uplift them. You can able to uplift them to much better fuel. As we know, bottom of the barrel, once upon a time, that after vacuum distillation, the bottom of the barrel, so the kachra of the petroleum crude were just thrown as a waste, or maybe as a pitch or turpentine, or maybe just asphaltene. But now those things are cracked, and as a result, we are getting designer fuel like speed and all those. Power and speed are made out of that vacuum residue, because those things we developed that technology to utilize it. So nowadays also we are using that oil and those things. And again, if you see that Punjab, Haryana, Delhi and all those, huge amount of biomass they just burn after harvesting, huge amount of biomass they burn. So instead of that, and that causes whole lot of pollution, soot and all those formation. So can we utilize it? It may be fermentation, it may be gasification. So which path to be followed and what should be the best combination? And that need to be figured out, and that is need of the hour. And the same paper is talked about that if you just opening of ring, they may not increase the cetane number, but they reduces soot efficiency. So you have some compounds. So if you can identify what are those compounds, if you do some chemistry, so by that, sometimes you can improve the cetane number, nothing like it. But even if you do not improve the cetane number, you can reduce the MPI. That MPI stands for sooting efficiency. So that micropyrolysis index. So if you reduce the sooting, so as a result, even if those things are burnt, they will form reduced soot. So check, the soot was almost 2018. It has been reduced to 13, 14. So obviously that is a sustainable development. That is a sustainable development. And again, I started with biodiesel. I'll make the loop complete. I'll again coming back to biodiesel. So biodiesel are nothing but triglycerides of methyl esters. And we know that they do stability problems with cold flow properties because viscosity, pour point, all those are high. And that causes the blendability aspects. So what is the problem? The problem is that all those are fatty acid, methyl ester of long chain fatty acids. Palmitic acid, stearic acid, oleic acid, and all those long chain length. So, but obviously from refining technology, we have that methodology. We know how to do cracking. We can do that. We can crack them. Some of the things, so if you recollect for tallow and for this coconut, we have a whole lot of unsaturation. So olefin content is more. If we have olefin content, we can do hydrogenation, hydrocracking, and all those hydrogenations are also well developed. So we need to mix and match. So we can utilize the technology which are already known, cracking and hydrogenation, in order to elevate those biodiesel to better and better source. But there are still 2 points which need more attention. One is ester group and free fatty acid. So let me go to next slide, which is self-explanatory. So here I have tried to draw a long chain fatty acid methyl ester. So all these are nothing but CH3 length. And deliberately I have taken coconut oil, so many unsaturations in between. And it is that carbonyl group and that O, that is that OCH3, that is the ester link. It is because of that, because of this, that oxygen content is more. And that causes, because of that oxygen content, your overall carbon content is less. And this oxygen is causing problem in burning. It produces corrosion and all those. So, and again, there are unsaturations. So just we have talked about the unsaturation we can do by hydrogenation. And we know palladium or some other type of designer catalyst can be used to reduce the unsaturation. Now comes the point of this removal. So we can do hydrogenation selected manner, in selective manner, so that we can reduce or we can crack and break out that that ketonyl group. And still, if we can just chop this out, cracking, what is cracking? Nothing but just to break it. By high temperature cracking, we can just break it out. If we break this portion, still we have a longer chain. So still a sufficient longer chain, and that longer chain is good enough to produce our diesel fuel directly. So please understand, biodiesel is not diesel. Biodiesel is FAME, fatty acid methyl ester. But by cracking, we can just break open this carbonyl portion, and we can have only free that length. In that also, if needed, we can do hydrogenation to get it structured alkane. But we want to use it for diesel. So in order to improve that CN is cetane number, in order to improve the cetane number, we can do alkylation, we can do some sort of isomerization, which is also well known, and all the refineries are doing it. So the isomerization and the cyclization and all those things are well known, and almost all grassroots refineries and almost all IOCL, BPCL, all refineries are doing it in day in and day out. And all our that designer fuel, like may you call it speed, may you call it power, all those are nothing but like this. That bottom of the barrel, so the long chain C30 or those are chopped, broken to smaller pieces, and as needed, isomerization and cyclization is done to make designer gasoline, so that we purchase it even 5-10 rupees more, so that to get better fuel efficiency. So exactly that thing is possible. So the chain length is so high, we can just break it out. We can have the hydrocarbon length. If needed, we can do hydrogenation. If needed, we can do alkylization or cyclization. And by that, we reduce viscosity, cloud point, pore point, each and everything. So that need out of the box thinking. It is not modeling. The technology is a complete gamut. It requires understanding. So that's why I'm not proposing any particular model. I am trying to unearth the understanding. So chemistry is trying to unearth the system in one aspect. Modeling is trying to unearth in different aspect. Experimentalist is trying to unearth it in different aspect. And all of us synergistically, if we can cooperate hand in hand, then definitely we can do something. So I'm closing. So cooperation among disciplines, instead of competition, if we do coordination among yourself, so we can do much better, because the engine, how those are operated, which range is, that thing mechanical people can definitely able to tell. Even that require more understanding of knowledge, maybe maths or maybe computer IT people will help us. Chemistry people will give the basic understanding what type of thing will be needed here. But definitely someone has to take the ownership to connect the dot and get a sustainable perception. And I always like this thing, go for simple thing if it is effective. We have observed that even simple blending is good enough, up to 5-7%. And that paper got published because we said that just back of the envelope up to 10% blending is good. And majority of the world, that 10% was good. So make life simple as long as it is fun. But at the same time, know how much you do know and how much you do not know. And definitely side by side invest. It's like that all the medicine companies, they keep on selling their product, but keep on investing for future generation drugs. So we need to think and invest our time, effort, and everything in synergistic manner, so that we unearth more and more about the process. So these are the references, and the slide will be available with you. And almost all of these things are available, and from internet you can able to get them. Thank you. Thanks for your kind attention. So,
Thank you, sir. Thank you.
quite some time.
Thank you so much, sir, Nandi sir, for your engaging talk. I request participants, if you have any questions, then you can either type them or you can ask them one by one.
Good evening, sir.
Sir, may I?
Please.
Yes, please.
Sir, how the modeling you have started, that you have told that you have learned about 700 or more than 700 papers regarding that. So in that case, either their data has been utilized to form that linear or unlinear or non-linear, whatever. I don't get anything at least. That's how this the modeling can be started at our levels of thinking.
Okay. Sorry if the information is not passed in proper manner. I really apologize for that.
No, sir, I am not belonging to the mathematical background. That's why I think I will not be able to get it.
Neither me. Basically, acidically, neutrally, by means, all means, I am chemical engineer. Okay. So I am also not from this thing, but definitely, as and when needed, I have toiled my hands with some sort of modeling. And I have used, I can maybe 18 or 23 research papers, and from that we collected about 750 or so data points. Okay, so those are data. So because there are Napier graphs for which you will get a whole lot of data. There are various types of biomass. So like kitchen waste till the showgram waste, then bagasse, all those. Okay, so in which it's very easy to get their quantified value in some range. That what is the range of cellulose, hemicellulose, lignin. So we have collected data, and I should admit that getting the data of cellulose, hemicellulose, lignin is much easier. But once then we thought of that because when we are taking kitchen waste, that time there are some amount of fat and some amount of other type of lipids, and all those are also there, okay, which are difficult to quantify. So we targeted to get some more data from that, but exact quantification of those data is getting that data is really tricky, and many of it require huge amount of effort to get for the specific biomass what is the lignin, hemicellulose and cellulose concentration along with lipid, because my idea was this, that this is not gasifier. We have used that biomethane yield. That's why you said biomethane. See the word. In gasifier, you can gasify anything and everything. That particular simple empirical model, the idea was biomethane yield. So by biomethanation, you can able to any sort of carbonaceous material with proper source of microbial consortia, you can able to make methane out of it. Okay, by methanogenesis and whole lot of other acidogenesis, and there are a series of steps Dr. Shadab sir talked about. So we are targeting that if we know for a particular matter what are lignin, what are hemicellulose, what are cellulose, can we give some rough idea this is the amount of methane to be obtained? So that was the first step. But in reality, that is good. So that model is fitting well, and I have shown you the data. But in reality, when you want to check the model, get validity for the real life data, for real life data, once you are getting the kitchen waste, getting real life data, simplest is kitchen waste. But in kitchen waste, always you have some amount of fat and all those associated. And the fat also, you can have consortia of microorganisms which may produce some amount of fat. So that's why we need to consider fat also as one of the important criteria which can produce biomethane. So, but point and again, I have not gone through any detailed understanding of the process, neither I have gone through metagenesis, kinetics. Ideally, that should be. It is just data driven. So just looking from the data, you can, if you have sufficient data, and fortunately, for last 2 years due to COVID scenarios, we have more time to spare to do Google, and in Google also so many things are available. You can literally get tons and tons of data, but definitely data accuracy and getting that data validity, and you should take from reasonable references. So you can get data and try to, now data science is, what is data science? That is nothing but extracting more out of the data. So even extracting some information, digging information out of data, that was my perception.
Okay, sir. So those papers and those references are actually for the methane production only, sir.
Those were for methane, because majorly for if you talk for gobar gas or whatever, so finally all those are producing majorly methane along with maybe carbon monoxide. But again,
Okay.
carbon monoxide, nobody bought because carbon monoxide is very toxic. Please try to understand,
Yes.
a very small amount of carbon monoxide is good enough to do chelate in your with the hemoglobin.
Yes, sir. Hemoglobin can react
So
with that.
that's why
Yes.
nobody wants carbon monoxide. We want to focus more on methane. Okay, so that's why the data available, with that we have targeted a simple model and we try to validate it.
So you use some mathematical equation to draw that modeling.
No, those models are just developed by simple Excel. In Excel, you have x1, x2, x3, and you are figuring out y based on x1, x2, x3. So one is that linear combination of them. Linear combination is not faring good. Then try some non-linear combination, and for that it is nothing but simple that inversion of matrix and all those are done, and by that it is being done. So if needed, we
Only
can
for exercise.
discuss 1:1, and I can share what I have done. Even
Okay.
simple Excel, I have done in simple Excel with just inversion of matrix. That's all.
Thank you, sir. Thank you.
But
Any more
the point
questions? I
you
think there was
talked about
one question.
that if you have real good this point, this refractive index, I will also think about. You also think about flashpoint. I think one of the but there it can definitely use that as a soft sensor. So try to utilize it for some better this thing, inferring something which
Okay,
are
sir.
difficult to measure.
Yes, sir. Thank you, sir. Thank you.
Sorry, Manda sir. Please go ahead.
Thank you, sir. Thank you.
No, I think someone else was asking the questions. I didn't get the name, so I was just requesting them to ask their questions.
So I'm just glancing through here, but
No, there is no question in this chat box. Yeah, I just
so basic my though I have kept it the title modeling is just to make so today is the end of the biorefinery and usage of biomass. So there are a whole lot of things. So at least that even I'm really passionate about reutilization of that COVID mask. Even I also throw them out, but I know that it is a crime I'm doing. But if we can figure out something, that will be really good.
yes, sir. That's a really good suggestion, actually. Okay, sir. Then, if there are no more questions, should we just close the session? And
Okay, sir. Thank you all the participants. So we understand it's a long day and almost.
Thank you, sir. Thank you.
So tomorrow again we'll meet sharp at 9. We'll start at 9, and we are maintaining that time more or less properly. So tomorrow is the day on solar and battery technology. And another point I should say that we are talking about sustainability, and we should be sustainable ourselves. And AICT has that views. So they categorically mentioned one session for yoga or something should be there, and so yoga or mindfulness. So we had Professor Vishakha Majumdar from Indian Institute of Management, Visakhapatnam, who will talk on mindfulness for our work-life balance, and that itself is a sustainable thing. So until and unless we are healthy and we are sustainable, we cannot do anything properly. So that session will also be very good. So tomorrow in morning there is a session on solar energy, and subsequent to that will be battery and energy storage. And afternoon session is work-life well-being, that mindfulness, and that is really I have a good fortune to hear her. So requested her to take a session. So she's a professor from IIM Visakhapatnam, by profession, psychologist, and a whole lot of other hats. But it will be a really good rejuvenating session, and will really for sustainability. I thought that should be the ideal person to have our own sustainability, so that we can deliver better. So we'll request all of you to join tomorrow also this session.
okay,
Thank you, sir.
thank you, Nandi sir, for your engaging talk. It was really informative, and I hope all the participants also enjoyed it. So, thank you so much again. I know you were very busy with all the coordination activities and everything, and still you actually managed to, give a very engaging, entertaining talk. So again, thanks a lot for this, and thank you all participants as well for engaging in this session. Thank you everyone. We'll see you tomorrow.
Thank you. Thank you. Thank you, sir.
Sir, one more query, last query from my
Please.
side, that whether the attendance link is also there, or we have to fill only feedback link.
No, attendance link is not there, only feedback. And
Yes,
your
I have
attendance
raised
is
that
already
query.
marked. Your attendance is
Yes, sir,
already.
already feedback is already given by me. Okay, sir.
And attendance is it is already recorded. You are talking, everything is there. So
Okay, sir, thank you.
don't worry for it.
Okay, sir. Thank you everyone.
Okay.
We'll see you
Thank
all
you, sir.
tomorrow in the morning. Yeah.
Thank you, Manda sir. Thank you.
Thank you, sir. Thank you everyone participate here.